So welcome back to my channel, and this is the first video and as well as the first lecture of physics class 11th. So we are going to start from the very basics, basically all about forces and its type. So we are going to delve deep into each and every force present around us, which we have to learn according to the syllabus of 11th. GCSE and ISC and NCRT or CBSE, all boards combined. I'm gonna teach according to any of the boards you can say, but from very conceptual manner. A note to be noted that I'm not gonna write a lot of things but explain more. So for the notes I will dictate things and you can write it out, and the most important things I will write. Okay, so let's start with the basic introduction of what is force. Force is a physical concept that describes, what does it describes? It describes the interaction between two objects that can change the motion of one or both of them. Okay, in simpler term, force is a push or pull that can cause an object to move, stop, or change its direction. Which this is the basic definition which we have been learning since maybe 5th or maybe more earlier. But before moving any further about what force is actually, let's actually know what mass is, because this will help us understand more easily. What is mass? Mass is something which is a fundamental property of a body. It's a fundamental property of a body. Fundamental means a basic thing, a base of everything. So it's the fundamental property of a body. Okay, alright. Mass is directly dependent on, just a minute. Alright, so mass, if I tell you, it depends on amount of matter present in a body. Amount of matter present in a body. More the amount of matter in a body, more is the mass. So we can say it's directly proportional. Okay, directly proportional. Yeah. And then second thing is, what we have to learn about is what mass actually is for. Why do we all have mass? Okay, that is amount of matter. Why is matter present in our bodies that make our body basically with some mass? Okay, so mass is basically used to oppose any change in velocity. So what it's used for? It's used for opposing any change in velocity. Okay, to let a body remain stable. This is the fundamental thing in science, where everything in this world have to go to a stable, that is, every body on this earth or in this universe wants to attain stability. That is, it wants to remain in the position of rest. According to science, the position of rest is called stable. So we often say, not logically thinking, greater mass is not actually considered good actually, but physically, or you might say scientifically, having more mass is something which is good, because more the mass you are having, the more stable you will be. Okay, now again back to the topic. Why do we need mass? First of all, to oppose any change in velocity, and then second of all, when mass opposes, then second of all, for attracting other masses. Okay, Now why do we have to attract other masses? Because it helps in, again, stability. It will help in stability of the body, because when mass attracts another mass, what will happen? For example, this is me and this is earth. The earth is attracting me towards it, and I myself is also attracting the earth, which is actually quite small, so we often neglect it. But never mind, we both are attracting each other. Why do we are attracting? So that I can stay on the ground, so that I can be stable. I won't be flying here and there, okay, on the sky. I can remain on the ground. Fine. Now, when mass opposes any change in velocity, this mass is called inertia, or we can say inertial mass. And when the mass is attracting another mass, this mass is called gravitational mass. Okay, but we know, but remember that these both masses, gravitational mass and inertial mass, gravitational mass equals to inertial mass, because we don't often write it, and 50% is my inertial mass and 60% is my gravitational mass. That both masses are same only. Okay, we are naming it differently. This is named according when the mass is doing what. When our mass is opposing a change in velocity, it is called inertial mass, but the mass is the same as the gravitational mass. Or when the mass is attracting another mass, it's called gravitational mass, but it is the same as inertial mass. So we have named it differently, but both are same thing only, inertial mass. So we don't often write it as mg or mi. We directly write it as m, simply denoting mass. Okay, now how do we know whether the force is we must have the knowledge about it, at least, even though it's not needed actually, whether to know the mass is inertial or gravitational, but we should know. Okay, so how to know whether the force is inertial or gravitational? So you will find it out from the question itself or the formula. If the question is describing, or a question or formula is describing g or g in it, then the mass will be used in that formula would be mg, that is gravitational mass. Not using, but actually I'm telling you that mass would be gravitational. But if g or g, big G or small g is not present, then it's inertial simply. Okay, so just for knowledge I told you, but that's logical actually, so never mind. Now let's move back to the force thing, which we were actually learning it. Okay, so I think that slide got deleted, but never mind, we will write it ourselves. What is a force? Okay, let's start from here. Force is simply a physical quantity. It is a physical quantity. Which changes the velocity of a body. when acted in an unbalanced form. When acted in unbalanced form. This is actually really important to know what this unbalanced force form means. This thing you might be it's understandable, it's quite understandable, because you know what actually force is. Force is a physical quantity which obviously changes the velocity of a body when acted in unbalanced form. This is something new. Okay, so let's know what it actually means. Okay, unbalanced form here means, you know, something that means the net force acting on it is not equal to 0. Okay, because we know that balanced force means net force is 0. Unbalanced would be where net force is not equal to 0. This net force is actually causing an object to either speed up or slow down or change its direction. So these all three things, speeding up, slowing down, or changing the direction, these all are changing the velocity, right? So that's the thing here. For example, let me help you differentiate between balanced and unbalanced force. For example, if I say some force is being applied on a wall, the wall is balanced here. That is, it applies, therefore it applies an equal and opposite force on any force that is being applied on the wall. So this force is balanced. That is, here is the wall and I am applying a force. Okay, but this wall is something really huge thing, and it's balanced because you know it's all constructed well enough. We can't move it anymore. So it's balanced from top to bottom really nicely. So even if we apply a lot of force here, it's not gonna change its not gonna change its velocity. We won't be able to. So this kind of force, this wall actually cancels out our force, external force which we are applying on the wall, and this cancelling out is happening because net force is equal to 0 when you minus it out, because equal force is applied by the wall on my hands also, right? So something like that, you imagine it. This is something balanced force. So unbalanced is opposite to it when you know when our force, net force, is not equal to 0. We are either making the object speed up or like slowing it down, speeding it up, slowing it down, or basically changing its direction. But together these all are changing its velocity, the velocity of the body, right? Something like that. Now let me tell you something more about it. For example, if force is being applied somewhere here and velocity is also here, then magnitude of velocity increases. There is an object, I am applying force here, and it's moving here only. So the magnitude of velocity increases here because the force is applying in the same direction as the particle is moving, right? So this force will add on into this, so this will make the particle or body speed up. Here theta value would be equal to 0, remember it. And because theta is 0, we will say that if you know, in 10th class we learned this formula, work equals ft cos theta. So cos 0 degrees, I think positive value only it will give, so positive work is being done here. Okay, now this was the case 1. Case 2, we will learn force is being applied here and velocity is here, that is a particle is moving in this direction but the force is being applied on the opposite direction. Here the magnitude of velocity will decrease because it's cancelling down, because it's opposing the motion of the particle, the force, this force, because here is the force being applied, this is the velocity. So something like that. Okay, here's the velocity. So v is decreasing here, and therefore theta value is here 180 degree, that is negative. Work done is negative. Why? Because cos 180 degree is -1, it would be negative. Okay, now the third case, when force is being applied perpendicular to the velocity. Okay, something like that, and only direction will change here. How? Let me tell you. So here only direction will change, because and the theta degree, theta is here 90 degree, because angle between them both is like 90 degree. Okay, so work done here is 0, but we are not going to learn here about work. I just told you as something you must know, because we have already learned this in 10th class. Okay, but what if a question arises, what if value of theta is not equal to 0 or 180 degree or 90 degree? Then what? Then both magnitude and direction of velocity will change. For example, like this, in an inclined position we are putting the force, applying the force actually, and velocity is something like this, and theta is something not 0, not 180, not 90, it's something, let us assume 60 or something, such a value, not these things. Okay, then here magnitude as well as direction of velocity will change. Okay, alright, we understood this. Okay, now let us quickly move on to the next topic, that is types of forces. Okay, what are the types of forces we are going to learn in this chapter is some basic 4 types of forces, which are actually the basic and the most important, and we are going to learn it, each of them in detail. So first of all is the gravitational force. I'm not going to waste my time writing force, so I'm going to just write F. Gravitational force, electromagnetic force, EM force. Okay, third is strong nuclear force, and fourth is weak nuclear force, or we can simply say it weak force. Okay, so these are the types of forces we are going to learn. First is gravitational force. So let's first start with gravitational only. In 10th class and maybe in 9th also, we have already learned what is gravitational force, but let's start with the very basic, that is the law of gravitation. What does the law of gravitation basically states? That law of gravitation states that every mass attracts another mass along the line of joining, whose value is given by F equals g m1 m2 upon r square. Let me repeat what I meant. Law of gravitation basically states that every mass attracts another mass along the line of joining. Okay, that means if there is two masses, one is this mass m1 and another is m2, This is the line of joining, right? Let me name it as R. So here both masses are applying forces, because we have already learned when we were learning the uses of masses, right? I told you that one mass attract another mass towards it. That mass is known as gravitational force, right? I told you this thing, gravitational mass, actually I told. So that gravitational masses, these are gravitational masses, and these are attracting each other, right? Now that is, they are attracting. How are they attracting each other? By applying forces on each other. Here these forces are called as gravitational force. Okay, gravitational forces. Now, so let us see the formula of this gravitational force is equal to G m1 m2 upon r square. R square is the line of joining the both masses which are attracting each other, and these are the gravitational masses, and this is gravitational constant. Okay, universal gravitational constant. Let me tell you what actually it means. Gravitational universal gravitational constant. Why did we name this as? Because this won't change even on another planet. Okay, so universal gravitational constant means, first of all, universal here signifies it will remain same in every condition. What? Let me repeat myself. In every condition, this value of G will remain same. Gravitational is something related to gravity, fine, and constant here means the value of G will remain everywhere, same everywhere. So these are the key points: every condition and everywhere. Universal means the value of G will be the same in every condition, and constant here signifies that the value of G will remain same everywhere, even on Earth, even on Mars, even on Venus, every planet and everywhere in the universe. Okay, and most importantly, why universal is applied? Because in every condition G value would be same. Now I'm again and again telling G value, but what it actually is, let us see. Value of G is equal to 6.67 into 10 power minus 11. Okay, and whatever the SI unit is, we write it. Okay, wherever we are using the value of G, fine. So yeah, you know what, actually the formula for this gravitational force was actually before it was actually something like that. Sorry, something like this: F equals G m, big M and small m. This m is mass of Earth, and this is mass of something, some body or object near the Earth's surface, upon R plus h by 2. This was the actual formula, and square. Okay, but why did it convert into this Gm m upon R square? Let me tell you. Because h by 2 is here telling that h by 2 here means the distance or the height of the object near the Earth's surface. This was the formula when we are taking gravitational force on Earth. Okay, so one body is earth, that is really heavy, and another is some object or body, maybe a satellite or something. So what is the force applied on earth? We won't count the force on applied on the earth because that would be very negligible. Earth is a big planetary object and this thing is very small compared to the earth, so we won't count the force applied by the body on the earth, no. But we will see what amount of force is applied by the earth on this body. We are interested in this thing, okay? So that's why the height of this body is not considered, okay? So we are not interested on the mass applied by the body on the earth, but the force applied by the earth on the body. We are interested in that, okay? So we won't count this also, that is the height of the body, that is this thing, because it is very negligible and can be neglected. It height of all the bodies on earth are obviously smaller than the earth's radius, okay? So we won't be counting that. That's what I was actually trying to explain. Now let me also tell you the formula for this g, gravitational acceleration or acceleration due to gravity, which is equal to gm by r square, okay? Because this is the formula, we often write it as F equals mg, because when you will see gm upon m by r square, this whole thing is g, what is left is small m, so mg, something like that. That's how this formula is derived, which is actually really important formula. Now what is this force? This is nothing but a force on an object of mass m by earth, okay? Something like that. Let me explain it. If this is the earth and there is some block kept on the earth, so the force on the block m, this is the of mass m, and this is earth of mass m, big M, and this is its center O, and this is applying some force on the mass and on the block, and the block is also applying some force on the earth, but it's negligible. And the line joining these both masses or forces are, or basically the radius of earth is r, okay? Simply like that. So the force on the block of mass m by earth is mg, vertically downward towards the center of the earth. This mg is towards the center of the earth, okay? Vertically downward. So that's all for today's lecture. In the next video we are gonna learn a lot about in detail about electromagnetic force and its types, because it would be very long thing. This will extend a little bit longer because EM force, electromagnetic force itself, has a lot of types, so we will be learning that also in detail. So bye.